Good morning, students. In chapter Gravitation, we have studied at what is gravity, what is a gravitational force, how the every object in the universe, like this pen and this copy, have attraction force between them. And though this pen and this copy have attraction force between them, but they can't move. This copy can't move this pen, or this pen can't move this copy towards itself, though they have the gravitational force. We know that the value of this gravitational force is so less that it can produce an acceleration in both of these two objects. But about the earth, what is about the earth? Earth has a huge mass, so the gravitational force exerted with the gravitational force exerted between the earth and the object is too large, so that an object can be accelerate with the attraction force which is caused by the earth. It means something which is on the earth. This is our earth having the mass m, and this is an object having the mass small m, and we know that the force of attraction is always in between these two objects. Like this object, this can be me, it can be you. So this force of attraction is always act between these two objects, like this one, or you can say it is you, and or it can be me and this earth. This force of attraction which is acting between both of these objects move this small object, but do not move this earth towards the object. It means just suppose this is the earth and this is the apple, and we know that apples always fall on the earth. If same force of attraction are acting between these two objects, means we know that force of attraction is equal to g m1 m2 upon d square. Now if the force of attraction is same for these two values, like the apple and the earth, if the force of attraction is same for these two values, then why earth do not fall on the apple, but we know that apples falls on the earth? What is the matter? Why it happens so? Because the acceleration F is equal to m into a. A is the acceleration here. In second chapter we will study about force and what is force, but now it is enough to know that F is equal to m into a, whereas as a is the acceleration. So if you want to find the value of acceleration, it will be F upon m. So acceleration produced in the earth is equal to the force divided by the mass of the earth. Now you can imagine the mass of the earth is so huge as compared to the apple. So the acceleration produced in the earth is negligible. But an apple has a very small mass as compared to this earth. So the acceleration produced in the apple is too large, so that the apple falls on the earth, but all earth do not falls on the apple. Okay, now these are some numericals which are related to the chapter gravitation. Both the chapters which are coming in our exams are based on numericals. This is the numerical. You can pause the video and you can write the numerical, and then after that you can play your video and you can understand how I am going to explain this numerical. Two object of mass 1 kg and 2 kg. First of all, you should write the values which are given in the question, like m1 is 1 kg and this is m2, it is 2 kg, are placed at a distance of 1 meter from each other. In universal law of gravitation, we have learned that the distance between them two objects is represented by d. It is equal to the 1 meter. And when two objects are kept at some distance from each other, there is a force act between them, which can be found by F is equal to g m1 m2 upon r square, या d square, where m1 m2 is the mass of the object and d is the distance between them. So now assuming that only the gravitational force acting on them, now the gravitational force is acting in those two objects, m1 and m2 are the two objects having the mass 1 kg and the mass of 2 kg, and the distance between two objects is 1 meter. Now you have to find the ratio of the acceleration produced in the two objects. To find the acceleration, first of all we have to find the force which is acting between two objects. For finding the force, we know that the formula is equal to G. I am not putting the value of G here because for finding the value, for finding then any ratio, we have to divide values with each other, and in division some of the values even cancel out. So I am not putting the value of G. If we need the value, we have to put the value of G. We can put it. Okay, G into M1. What is M1 here? M1 is 1 into M2. M2 is 2 upon R square. D square, sorry. D is the distance between them. So the force which is acting in both the object is equal to 2G. Okay, the value of 1 is 1. By multiplying with the 1 with the 2, it will be 2 only. So the force which is acting between the two objects is 2G, where G is a universal gravitational constant. Okay, if you want to find the acceleration produced in the M1, I am writing here the acceleration by A1, and the acceleration produced in the mass M2 is A2. So the acceleration produced in the body of mass 1 kg A1 is equal to F upon M. According to this formula, we know that F is equal to M into A. For finding the value of A, we have to write it like F upon M. Now put the value of F, which is equal to 2G upon M. What is the mass of this object? It is 1 kg. Okay, equation 1. Second, for the finding the value of acceleration produced in this mass M2, A2 is equal to F upon M2. What is the value of F here? F is 2G. Because equal force is exerted in these two objects. 2G upon, what is M2? M2 is 2 kg. We can cancel out 2 by 2. Okay, this is the equation. Second, now you have to find the ratio of acceleration. It means you have to find the value of A1 upon A2. A1 is 2G upon A2 is G. Cancel out. How much is the ratio? 2:1. So this is the acceleration produced in these two objects. Okay. So some numericals which are based on this chapters is like based on the force. It can be related to the acceleration. Okay. We have already learned that. We have already studied that. For an object which we throw in upward direction or which we falls towards the earth, which we drop towards the earth. For these two objects, the acceleration is always represented by the G, and the distance is represented by the H. So by equation of motion, we can write the equation of motion is equal to, like first equation of motion, V is equal to U plus GT. Second equation of motion, H is equal to UT plus half GT square. I've already explained all these terms in last lectures. And V square is equal to U square plus 2GH. These are the three equations of motion which we use in this chapter for numericals. Now the second numerical is, a ball is thrown up with the speed of 15 meter per second. Okay, how high? Is thrown up with the velocity of, it means this is the initial velocity of the body. Initial velocity is how much? It is 15 meter per second. This is the initial velocity of the body. Sorry, okay, I should move my copy here. Sorry. Okay, now a ball is thrown up with the velocity of this one. So this is the initial velocity of the ball. How high will it go before it begins to fall? You know, if something is thrown in upward direction, it attains its maximum height, and after that it begins to fall down, and its maximum height, when it attains its maximum height, its final velocity becomes 0. So we know that if we throw something in upward direction, after attaining the maximum height, its final velocity will be 0. Okay, before it begin to fall. Now the value of G is 10 meter per second square in the question. If here is not writing the value of G, we will put the value G is equal to 9.8 meter per second square. What we have to find? How high will it go? How high means we have to find the height of the object attained. So which value, which equation of motion we should use? We should use third equation of motion. V square is equal to U square One more thing, we know that if we throw something in upward direction, the acceleration goes on decreasing. Since its velocity goes on decreasing, so we can say that not acceleration decreasing, its acceleration is in with the having the negative sign. So if we throw something in upward direction, the acceleration will be negative. V square is equal to u square minus 2 into g into h. Okay. Now 0 is equal to 225 minus 20 into h. It means 20h is equal to 225. Then h is equal to 225 divided by 20, or by dividing it you can find the value of h. 11 point approx. Now the third question, stone, sorry, it's not a stop, a stone. A stone is dropped from a cliff, or if we drop something, we know that initial velocity of the body will be 0. What is its speed after it has fallen 100 meter? When we drop something from a certain height, it's begin to fall with an acceleration which is equal to the acceleration due to gravity. It means if we drop something, the acceleration produced in the body will be equal to the acceleration due to gravity, which is equal to 9.8, or if it is in the question, that is 10 meter per second square, so you can write that value 10 meter per second square. It has fallen 100 meter. Now not at the ground, we have to find that if we fallen 100 meter, after 100 meter how much will be its velocity. So height is 100 meter, and how much velocity will it gain, we have to find it. Okay, for this question, which equation of motion we should use? We should use third equation of motion. So we are using the third equation of motion here. V square, oh sorry, it's not 0, V square is equal to u square plus 2 into g into h. Okay, now v square is equal to how much? It is 2000, and v will be square root of 2000. You should know how can we find the square root of this value, by using the long division method, which you have learned in last class, in 8th class. By pairing these values, we can find the square root of the 2000, like 4 4 ja 16, 4, right here pair, and we will write here 8. Now table 1840, it will be 5 times, but 5 times it will become larger, so I am writing here 4 4 4 4 ja 16, 1 carry 32 33. Okay, 4, and again after subtracting it, we will get 936 and decimal, and then a pair of 0, 88 here. Now it will be approx 44 point approx, we can say that it will be near about 6 can be. So the value of v is equal to 44.6 meter per second. This is the value of v. So we should know which equation of motion we have to use to solve our question. Now the next question is this: a paper weight thrown upward attains the maximum height of. A paper thrown upward, if we throw something in upward direction, we have to give it some velocity, but here is no the value of velocity. Attains some maximum height. If something is attaining its maximum height, it means its final velocity become 0, and the maximum height h is equal to 19.6 meter. Find the velocity with which it was thrown. Now the value of g here is 9.8 meter per second square. You have to find the u, initial velocity of the object. So which equation of motion we should use here? We should use the third equation of motion, that is v square is equal to u square minus 2. Why minus? Because we know that we are throwing something in our direction, so acceleration will be negative. Minus 2 into g into h. H is how much? 19.6. Okay, now u square will be 19.6 into 19.6. So the value of u will be square root of 19.6 into 19.6. It will be 19.6 meter per second square. It's not second square, sorry, meter per second. Okay, now the next question. Questions are not so typical, but you should be clear about all the equation of motion and how can we use this equation of motion. A ball thrown upward attains the maximum height of. Attains the maximum height means we are giving the value of v is equal to 0. Thrown upward attains the maximum height of, not of, in 5 seconds. It means the time here is 5 seconds. Find the velocity with which it was thrown. You have to find the value of u. Now here is no the value of g, so I am writing here 9.8 meter per second square. Or if we throw something in upward direction, the value of g will be negative. So which equation of motion we have to use? I think we have to use the first equation of motion here. V is equal to, okay, we have to find the velocity of, sorry, not 0, it is question mark. We have to find the velocity of initial velocity. V is equal to u minus g into t. So u will be how much? 49 meter per second. So these are some numericals. If you get some problem in numericals, I will giving you a sheet. If you get some problem in numericals, you can ask me in your group. You can even call me. I will explain all those questions. Okay, bye.